Look, good morning, everyone. It's a real honour to be here today and representing SafeWork New South Wales and also TestSafe Australia. Having testing facilities and NUTA accredited laboratories and facilities within those has always been a passion of mine. So I'm really happy to come along today and speak to you about that, and also why accreditation matters and what it means to us. So today I want to share with you how we build trust through rigorous testing, maintaining accreditation and ensuring safety in various industries. So our work impacts a wide range of sectors, from construction and manufacturing to health and to education. But at the core of everything we do is a simple yet powerful message and principle, and that's safety first. So first of all, I'd like to begin talking about who we are and what we do at SafeWork New South Wales and also at TestSafe Australia. And some of you may already know about us, and we might have even paid a visit to your premise in the past. So first of all, a little bit about who am I, and it's good to see some old colleagues here today. I guess by trade I'm a medical scientist, and I have about 29 years experience working in laboratories and testing facilities, and all which have been NATA accredited. So I spent 10 years in private pathology, 14 in public pathology, and then moved across for 3 years in forensics and environmental, and the last couple of years around material assets and products. My previous role, or my past role to this one, was Director of Operations at New South Wales Health Pathology, and I was based at Westmead and led a pretty significant team of around 700 people across 7 sites in the Western Sydney and the Nepean Blue Mountains area. We were pretty busy during the COVID-19 pandemic, as I'm sure many of you in the room were and still are currently. And I just want to say thank you to all of you who are still going through that and still working really hard to deliver great services and health. So who's SafeWork New South Wales? So we're the New South Wales Workplace Health Safety Regulator. And our primary responsibility is to administer, provide advice, monitor and enforce compliance with the Work Health Safety Act 2011 and the Work Health Safety Regulations 2017. And there's a couple other bits of legislation that we also take carriage of. Our mission is to ensure that every worker in New South Wales is able to work in a safe environment and returns home safely at the end of each day. So we offer advice on improving work health safety in workplaces, and our team works to provide practical guidance to businesses and workers, and we help them implement effective safety practices and also to mitigate risks. So by fostering a culture of safety, we aim to prevent workplace injuries and illnesses before they occur. So in addition to offering some advice, we provide licences and registrations for potentially dangerous work, and that includes activities such as operating heavy machinery, handling hazardous materials and performing high-risk construction tasks. So our licensing processes ensure that only qualified and competent individuals undertake these high-risk activities, and thereby reducing the likelihood of accidents and incidents. Investigating workplace incidents and enforcing work health safety laws in New South Wales is another critical aspect of our role. When incidents unfortunately do occur, our team conducts thorough investigations to determine the cause and contributing factors. We then use these findings to enforce compliance with the work health safety laws, and we ensure appropriate measures are taken to prevent future occurrences. So our enforcement actions can range from providing educational resources to imposing penalties for non-compliance. The principles that guide our engagement, though, are transparency, purposefulness, respect, collaboration and inclusivity. We believe maintaining open and honest communication with all stakeholders is essential to building trust and achieving our safety goals. So our purpose-driven approach ensures every action we take is aligned to our mission to protect our workers. We treat everyone with respect, and we recognise diverse perspectives, experience that contribute to the safe work environment, and collaboration is at the heart of our efforts as we work closely with businesses, workers and the community to develop effective safety solutions. So with more than a third of Australia's entire economic output coming from New South Wales, the work we do to make workplaces safe is very important. So I'd now like to introduce to you TestSafe Australia, of which I'm the director. So TestSafe sits within SafeWork New South Wales. We're a government entity and report to the Minister for Work Health Safety and Industrial Relations via the head of SafeWork. We've been in operation since 1964, so we're about to turn 60. And our role is to keep workers across the world safe, and we do this via our testing and certification of equipment and testing of workplaces and workers for occupational exposure. Within TestSafe, there are 3 distinct services, and we're split across 2 campuses. We have a campus located at Londonderry, up near Penrith, and one at Thornley in Sydney. And our services are NARATE accredited, and so we apply the highest standards of quality. So our chemical analysis laboratory is based at Thornley, and they analyse exposure to chemicals used in the workplace to determine if occupational exposure levels and safety standards have been exceeded. Some of the examples of the testing they do might include pesticides, phenols, acids, asbestos. And we also have an electrical testing team. They're based at Londonderry, and they perform a wide range of tests and issue certificates of compliance through the International Electrotechnical Commission system for equipment used in hazardous or explosive atmospheres, and that's the IECEX program, and also the Australian Certification Recognition System for hazardous area equipment, and that's the ANZEX program. Examples of some of the things they test for are motors, shot firers, lighting that's used underground, and also some dispensers like fuel dispensers. The mechanical testing team, also based at Londonderry, test mechanical equipment for compliance to national and international standards to ensure that they're safe for use in hazardous environments. And some of the examples of the equipment they test are conveyor belts, fire extinguishers they perform rating on, diesel engine emissions, PPE and non-destructive wire rope testing. So for us at TestSafe, accreditation is directly linked to safety. Okay? We understand the importance of safety, the reliability of compliance in today's global market. And as a trusted part of SafeWork, we're committing to upholding the utmost standards of safety. I'd just like to show you a short video that shows our facilities and some of the work that we do.
Are you looking for world-class chemical, mechanical and electrical testing? Or product certification for Australian and international markets? IECEX and ANZEX. Well TestSafe Australia can help. Visit nsw.gov.au and search TestSafe to find out more.
Okay, we'll move on to certification and reporting. And to better understand the requirements and implications of certification and test reports for manufacturers, especially in terms of worker safety and regulatory compliance, I'd just like to break down the main points. So certification for manufacturers. So the purpose of certification, a formal process. It verifies that a product meets certain safety, quality and performance standards. And for manufacturers, obtaining certification for products like motors used in mines ensure that these products comply with local regulations and safety standards. In terms of regulatory compliance, in Australia, those products that we do use in specific environments, such as mines, have to adhere to stringent safety standards to protect workers. So certification indicates compliance with these standards, allowing the product to be legally sold and used within the country. Market access. Without certification, manufacturers may not be able to sell their products in the particular market. And then looking at test reports. So evidence for compliance or of compliance. Test reports provide detailed documentation of the product's performance under various conditions. And for example, as of 1st July, engineered stone needs to contain less than 1% crystalline silica for sale in New South Wales to be sold and installed in your kitchens. Product safety and performance. These are really crucial for demonstrating that the product's safe for use and that it performs as expected. And they can be part of certification process or used to support claims about the product's features and its benefits. And regulatory and market requirements. So in industries with really strict safety and environmental regulations, like construction, test reports are often mandatory. For example, diesel engine emissions testing is really needed to ensure engines meet environmental and safety standards. So certification and test reports are fundamental for manufacturers to ensure their products are safe, that they meet regulatory requirements, and that they can be legally sold in specific markets. So this not only protects workers, but it also ensures that products are environmentally compliant and do perform as expected. So we understand the importance of accurate, reliable testing in order to maintain industry standards, and therefore we protect worker safety. So without accreditation, we would not be in a position to be able to provide such a service, and nor would our clients rely upon us. So I'd now like to look at a couple of case studies. The first being silica testing, which is a contemporary issue with the change in legislation, as I mentioned, coming into effect on the 1st of July. And crystalline silica, it's a hazardous substance. It's found in many workplaces. It's a common material used in building and manufacturing. And materials and products containing crystalline silica include shale, sandstone, concrete, bricks, and engineered stone, manufactured stone. Workers can come across this crystalline silica when they're excavating, or maybe they're tunnelling through quartz and some rock. And a health hazard's created when the very fine particles of crystalline silica can become inhaled. So the size of the fraction of the airborne dust that can be inhaled or that can reach the lungs, where air exchange does take place, is known as the respirable fraction. And once particles become about greater than 7 microns, they're no longer able to be inhaled. Significant levels of airborne dust are most likely to occur when materials or products in the workplace are cut, when they're sanded, drilled, or during any other activity which creates really fine dust. And exposures in workplaces can also occur through dry sweeping and using compressed air rather than wet cleaning or using appropriate vacuums. And it can also occur during resuspension of settled dust from clothes or fabric. So respirable crystalline silica, or RCS, depending on the factors such as how long a worker has been exposed and how much they've actually breathed in, can cause silicosis. So silicosis is a fibrosis or a scarring of the lung, and it results in a loss of lung function. So the fibrosis is incurable, and it does continue to develop after exposure has stopped. So persons with advanced silicosis, they suffer really bad, severe shortness of breath. They may suffer other complications as well down the track, such as heart failure and eventually death. So applying adequate controls, such as minimising the generation of airborne dust, can reduce hazardous exposures, and it can prevent illness in the workplace. However, elimination of the hazard is preferable. So RCS has a workplace exposure standard of 50 micrograms per cubic metre, averaged over 8 hours. So testing for crystalline silica is crucial to ensure safety of the workers and safety of community. So what sets us apart is our advanced testing capabilities and the research and the development that we undertake. So we have really low detection limits and they allow us to meet and exceed industry standards. We see that X-ray diffraction is the gold standard for testing of silica in air and also of testing silica in bulk. And as I mentioned, the exposure limit is 50 micrograms per cubic metre, but the Thornley lab has attained accreditation to go much lower, down to 2.5 micrograms per cubic metre, which means that perhaps we're one of, or the only, laboratory in Australia capable of reaching that level of sensitivity. Okay, so that means that we can really stay on top of those exposure limits and be ahead of the game. Being accredited means that our rigorous testing and, through our rigorous testing and long-term expertise in the field, our reports are trusted, and we're not only able to protect the community by meeting their expectations, but also able to support industries complying with safety regulations. We see that safety is a shared responsibility, and by partnering with community and industry stakeholders, we can achieve the best outcomes. The second case I want to have a look at is conveyor belt testing. And so we test conveyor belts to determine that they're safe to use in these hazardous environments, such as underground coal mines. And fire-resistant anti-static testing, or FRAS, is generally used on equipment that is in use below the ground in underground coal mines. It can be used in power plants, sulphur conveying, and some other high-risk areas. So belting accessories, including things like scrapers and skirting, liners, lagging materials, can be tested for fire-resistant and anti-static properties. And essentially, these components of the products play a vital role in minimising the risk of a catastrophic event. So the purpose of the testing is to minimise risks to health and safety of people from the use of this equipment. And this testing is conducted to determine whether the plant or component has fire-resistant anti-static properties to manage the risks associated with accumulation of a static electric charge, fire initiation, fire propagation, or toxic products of combustion. So at our Londonderry facility, we have an above-ground mine shaft constructed that mirrors the properties of an underground mine, including wind draft, and it essentially simulates the conditions experienced while these belts are operational underground. We place a sample of the conveyor belt onto a cradle and then place a gas burner underneath it for ignition source, as you can see in the picture. In Australia, we're the sole accredited provider for this type of testing. So fire resistance materials are those that when exposed to a flame or to heat, they are difficult to ignite. And once the flame or the heat source has been removed, combustion of the product ceases. So a fire-resistant product should never be the source of a fire and should not be the fuel that propagates a fire. We also run the belt through a rig, uses a motor to drive a drum, and that rubs on the belt and creates friction. Okay, and it imitates a jam pulley or a roller that rotates under a stationary belt. And this creates significant heat and noise, but should not cause the belt to ignite. The surface temperature needs to remain below 325 degrees Celsius, and no flame or glow should be visible. An electrostatic charge can build up on the conveyor belt surface, and it can ignite a mixture of flammable gases in the underground coal mine. And therefore, surface resistance must stay below certain limits. We also take a finger-sized sample of the belt and place it under direct flame. After the time, the burner is retracted and the duration of that flame then recorded. And we also undertake an oxygen index test. And that standard procedure is to ignite the top of the sample and you use a gas flame. And when that's withdrawn, we find the lowest oxygen concentration in an upward flowing mixture of nitrogen. And that supports the sustained burning. And that's how we measure that index. So in essence, the testing determines if underground equipment and materials continue to burn. It's something that's critically important in any environment, but specifically in hazardous environments. And being accredited for this testing ensures our methods meet stringent requirements, and this in turn delivers quality and confidence in our test results and ultimately it ensures that workers are safe by having only compliant equipment in use. So why accreditation matters to us? To recap, we have really quite advanced testing services and commitment to best practices. We have low detection limits that ensure we meet and exceed standards. But accreditation plays a crucial role in ensuring reliability and credibility of our testing. It ensures the quality of our testing regimes and accuracy of our test results and our test reports. It allows us to build trust with all of our stakeholders and drives us to provide the best service to our customers and the community. So adherence to and assurance to that testing facilities meet quality standards ultimately ensures safety of workers. So safety, as I mentioned, is a shared outcome for all stakeholders, be they manufacturers, organisations or workers, and it is the most important benefit of accreditation. So at SafeWork and at TestSafe, we're really committed to maintaining high standards of accreditation, committed to maintain high safety standards through ongoing collaboration and partnership. So SafeWork has launched a campaign called It's the Safe Way or the No Way, and that commenced on the 13th of May, and you may have seen some of that. It's been broadcast on different platforms, it's been on radio, it's been in print, and also direct emails to businesses and consumers. So our key message is together we say no way to unsafe practices. And some of the things that we're focusing on: falls from heights, moving plant and equipment, food rider delivery, and unsafe work in seasonal workplaces. And that's just another little takeaway from today.
Fantastic presentation.
Thank you.
I'm just still puzzled. The issues about silica dust were known back in the early 90s. Why has it taken 30 years to start to clamp down on these little corners of the industry sector that ignored silica dust issues?
It's a really good question. I'm not sure that I have the answer. I think it's long overdue. I think there's some really good work being done currently, but I'd agree, long overdue. I mean, silicosis is an awful disease. Many people affected and impacted. I've lost people that I went to school with that have grown up and were stonemasons, and others who have passed on. It's I guess it's been around for too long, but now something, I suppose, hopefully positive can happen with bans that are coming in place, with greater controls that are being implemented. But yeah, it's been a long time.
Can I ask the question in a different way again?
Sure.
So in the road construction industry, we've got the chain of responsibility, which has a very good impact at the moment. So if I ask the question again, why hasn't the chain of responsibility been applied to the silica dust issue? For example, Bunnings could have banned the product. They've well known this for years as well. But because there's no legislation to the chain of responsibility, they can just, it's not my problem.
Yeah, that's right. And look, I'm not sure whether it's because, the delayed onset of disease, that sort of, I guess there's a lead in time for people to actually fall ill and to become really ill, and then patterns emerging and identification of, I guess, clusters and people exposed to silica dust. There's really no. It would have been lovely to have done it, I think, a long time ago, but unfortunately it wasn't. And we're sort of catching up now.
Thanks, Chris. Thank you very much. Can everyone please thank Chris for his presentation?